This is the tutorial for the 3.1 3.2 quiz, and so let's take a look at our first type of problem, and it's going to ask us to use the figure to find the measure of the angles and then explain. And so first step I'm going to end up doing is I'm going to see that I've got parallel lines. Whenever I've got parallel lines, that means all the acute angles that are formed are going to be equal, and all the obtuse angles that are formed are going to be equal. And so I'm going to find out what the other angle is. So I'm going to take 180, since a straight line makes 180 degrees. If this is 84, angle 1 is going to be 84 subtracted from 180. And so when I do that subtraction, I end up getting, in this case, having to borrow a bit, and I get 96. And so from there, I can go ahead and come up with my other values. So let's go ahead and take a look at our first angle they're looking for, is 6. And so what we have to do is not only name the angle, but explain our reasoning, how we ended up coming up with that. So one thing I'm going to state right at the beginning is that we've got lines are parallel. Lines are parallel. And so when the lines are parallel, that tells us that we've got certain scenarios, like for instance, alternate interior angles are going to equal. We've got corresponding angles are going to end up equaling. And so whenever we have these parallel lines, we'll have this case. And so when I look at 84 and 6, they are alternate sides of the transversal, and they are outside. So we call those alternate exterior angles, and those are congruent. So angle 6 would end up equaling 84 degrees. And I could say alternate exterior angles would be the reasoning there. And for angle number 5, I would say, well, it's going to end up being supplementary to angle 6. So it's going to be the other angle. It's the obtuse angle. It's 96 degrees. And so we could say that it's supplementary to angle 6. Now angle 4 is vertical to angle 6, and it's going to be exactly the same, because all vertical angles, no matter whether we have parallel lines or not, because vertical angles, all we care about are two angles that share the common vertex, and so that are opposite one another. And so angle 4 is going to end up equaling angle 6, which is 84 degrees, and we could say vertical to angle 6. And so angle 7, well, that one's vertical to angle 5, and so that's going to end up equaling 96 degrees. And so we could say vertical to angle 5. Now there are lots of other ways to signify that we've got a certain angle, and that's what this next problem is all about. It's giving us two ways to find out what an angle is. And so we're trying to find angle 5 in this case. And so again, we've got parallel lines, we've got acute angles and obtuse angles. All the obtuse are going to be the same, all the acute are going to be the same, because we've got parallel lines cut by a transversal. So the first thing I'm going to do is I'm going to go ahead and find out what that other angle is going to end up being. And so when I do that, all I'm going to do is subtract 34 from 180 degrees. And so in this case, I end up getting 146 degrees. And so I know all the angles that are like angle 1, 3, 7, and 5 are all going to be 146 degrees. So how can I find angle 5? How can I explain that? Well, we could say a few different ways. We could say, for the first way, I'll say that angle 4 is equal to 34 degrees because it is the alternate interior angle to the given angle. And then I could say, well, angle 5 equals, and this is the answer there, 146 degrees, because it's supplementary. Well, 5 equals 146 degrees, supplementary to angle 4. So that is one way we could end up doing it. Another way would be to say, well, angle 34 is the same as 6, because those are corresponding. So we could say angle 6 is equal to 34 degrees, because those are, we could say, corresponding to given. And then we could use the same logic we did in the last one. We could say angle 5 is equal to 146 degrees, and we could say it's supplementary to angle 6. So those are two different ways, and again there are other ways as well. Well, here it says the lectern has four vertical angles, or vertical sides, and a slanted top. That's what we end up seeing here. Find the measure of angle 1 and angle 2. Well, when we look at it, you see how we've got this straight line, and it's cut by this line right here is going to end up cutting these two parallel lines. So this is one parallel line here. This is the other parallel line here. And so you can see how these are both internal angles inside the two parallel lines that we have. And so when I go ahead and find angle 1, all I'm going to do is, since that makes a straight angle with the given, I'm going to subtract 68 from 180 degrees. And so when I get that, I end up with 112 degrees. And so from there, I'll know that angle 1 equals 112 degrees. Now angle 2 is going to end up being the same as angle 68 because they are corresponding. So I'll say this is supplementary to given, and then I'll end up saying that angle 2 equals 68 degrees, and the reasoning on that was that we have corresponding angles here, corresponding to given. And that's the key. Remember when it says explain the reasoning, that's what I'm doing here with the writing. So let's take a look at the next problem, and it says just find the measure of the interior angle. Well, we know that all angles in a triangle sum to make 180 degrees. So that's what we see here. So what I'm going to do is I'm going to add up these two angles here, and that gives me 164 when I add the 39 and the 125. And so then I have to subtract that from the 180 degrees to solve that equation. So we'll go ahead and subtract 164 from both sides, from that 180, and when I do so, I end up with 16 degrees. And that would be the value of x, or the missing side there. So two of the angle measures are given, and just that third one was missing. Here it says, find the measure of the exterior angles. Well, a rule with exterior angles is they equal, this is their exterior angle here, it equals the two interior angles that are further from it. And so what we can end up doing is taking that 2x and the 3x minus 12 and adding those two together, because it'll end up equaling this amount. And the reasoning is this, is that all angles in a triangle add to make 180, straight lines add to make 180, and so this missing piece right here must, along with the sum of these two, equal 180, but also this missing piece plus this piece must also equal 180. So we're going to go ahead and set these two remote interior angles equal to this exterior angle. So when we go ahead and do this, we got 5x minus 12 equals 4x plus 9. And then I'll go ahead and do some opposite operations. I'll subtract the 4x from all sides. Leaves me with x minus 12 equals 9. Then I'll go ahead and add the 12 to both sides, and I get x equals 21. But I'm not done yet, because it says find the measure of the exterior angle is what we're trying to find. So we have to take this angle right here, this expression, 4x plus 9, and substitute that 21 in for x. So when I go ahead and do that, I have 4 times 21 gives me 84 plus 9, ends up giving me 93 degrees. And so that's the answer that I'm looking for there. 93 degrees is that exterior angle. Well, this one here says a ladder is leaning against a wall, forms a triangle and exterior angles with the wall and the ground. So here's one exterior angle, the wall with the ground, the ladder and the ground, and then right over here we have the ladder and the wall. So we have two different exterior angles that we're going to be looking at here. What are the measures of those exterior angles? So we're just going to take the 5x, the x, and the 90, and I'm going to add those together. And I'm going to find out what x is. That's the way I'm going to solve this problem. And I know they sum together to make 180, so when I go ahead and combine these, I get 6x, but then I have to subtract that 90 from both sides, and I get 6x equals 90. So when I go ahead and do the division, dividing by 6 there, I end up with x equals 15. So now I can find out what this angle is. Well, for instance, I can do this one right now. So with the ladder to wall, that exterior angle is going to end up being, since x equals 15, I'm going to take 15 away from 180 degrees, and that's going to give me 165 degrees. So that's one of them. And then I'm going to end up doing the same thing with the next. I'm going to do ladder to ground, but I've got a little bit of work to do here because I have to multiply 5 by 15 first. So 5 times 15 gives me 75 degrees, and then I can do the subtraction. 180 minus 75, that gives me 105 degrees. So let's take a look at the next few problems, and here we are trying to solve the equations. So I've got 1/6 d plus 2/3, and then I've got equals, and I'm going to do 1/4 d minus 1/2. Now I got the 1/2 because I did 1/4 times d is 1/4 d. 1/4 of 2, so that's like 1/4 times by 2. So think of 2 over 1, and I've got a little bit of reducing I could do there. So that's where I'm getting 1/2 from. So now it might be a little bit complicated. We could get rid of these fractions by multiplying by a number that would cancel out all those fractions. So I'm going to choose to do that. I see 12 goes into each of these numbers. So I'm going to multiply every number here by 12. And so I write 12 next to each of the terms so that you can see the cross-canceling that goes into effect. See, 2 goes into 12 6 times, 4 goes into 12 3 times, 3 goes into 12 4 times, and 6 goes into 12 2 times. And then I multiply across, and now I've got a problem without fractions. So now what I could end up doing is solving for d with a little bit more of an ease here because there are no fractions in the problem. So I'm going to subtract the 2d from both sides. So I'm still left with 8 equals, now this is just going to leave me with 1d minus 6. So from that point I'll just add the 6 to both sides, and I'm getting 14 as the value of d. So let's take a look at this next one. It says to describe the figures are, the two figures are congruent. Describe a sequence of two transformations that places the figure on the left to the figure on the right. So this is our image here. This is what we want to make. So let's go ahead and start here. So I'm going to take this item, or this triangle, and I'm going to rotate it, because it definitely needs to turn. So I'm going to rotate. Now when I rotate, I'm going to rotate counterclockwise 90 degrees about the origin. And when I do that, what's going to happen is this point right here, which is 4 spaces left and 3 spaces down, is now going to go 3 spaces right and 4 spaces down. And then this point right here is going to stay exactly where it's at because it's about the origin. And we'll go with this point right here. It's just 4 spaces to the left. So it's going to do the opposite of that, which is 4 spaces down. So now I've got this shape right here. And it looks exactly the same as this one. All we have to do is move it. So that's what we're going to do next. So we rotate counterclockwise 90 degrees about the origin, then translate, and it looks like we have to go up 1, 2, 3, 4 spaces. So translate 4 spaces up. Well, the last one here says the student's rectangular desk is 30 inches long by 18 inches wide. So 30 by 18. Now notice I put long on top, wide on the bottom. So L on top, W on the bottom. And so when I look at this, it says the teacher's desk is similar to the student's desk and is a length of 50 inches. So length on top And what is the width? We don't know how wide it is. That's going to be our unknown. So I could go ahead and cross-cancel now, but I'm going to reduce the fraction a little bit. I'm going to take out a common factor here. I see 6 goes into each of these numbers. It'll make the math a little bit easier on me. So this is 3, this would be 5, and now I'll go ahead and multiply. So I have 5x equals 3 times by 50. So 5x equals 150, and when I do the division, x equals 30. So 30 inches is the width of the teacher's desk. So now they want to know ratio of teacher to student desk. So teacher on top, student on the bottom. So just take some of the numbers. I'm going to take the length. So teacher on top, so this teacher's length is 50, and the students on the bottom. So now since I started with length, I got to continue with length, and it is 30. And they wanted the ratio of teacher to student. So I can't do student to student. I can't do 30 over 18 because that would be the student's length over the 18 student's width. And so it's got to be teacher to student, and you got to use the same corresponding sides, so length to length. And so when I go ahead and cross off these zeros, that's dividing by 10, I'm left with 5/3. And that would be my answer there. So those are the problems for this week's study guide.